As we have completed our introductory part relating to the queuing theory, different characteristics, queue disciplines, elements of a typical multi-line structure, we are now ready to go directly into the numerical. So today we will start the model number 1, and it is of single server Poisson's arrival, and it will be with exponential service and with infinite population model. Okay, m/m/1, and it is FCFS, that is the first come first serve, /infinity and infinity. So I have written the total formula list which we are going to use in this particular model, and we are going to solve numericals based on this formula list only. So you can have a notebook and write it all over, or you can take a screenshot because we are going to memorize these formulas and we are going to use these formulas to solve numerical problems. Now coming to these formulas, let me say a few words. Look, the direct formulas are given in the book, okay, and there is no derivation particularly given over in the book, but if you want derivation, I can give it to you in a separate session. You can comment me in the comment section, but I think the derivation part is not necessary, as because in queuing theory particularly, they are not going to ask you how to derive this particular formula, or in any other examinations you can take, they are not going to generally ask you to the derivations of this particular formulas. They are going to directly ask the questions based on numericals only, and where you have to apply these formulas directly to get solutions. So I think it is better to memorize these particular formulas. There are fewer months, and you need not to worry about the memorization process, as because you can see from these particular figures, they are very short one, and you can easily remember after solving one or two numericals. So I think it's better to solve and practice more and more problems, numericals related to these particular models, and after solving 2 or 4 numericals, I think it will be enough for you to get memorized and acquainted with this particular formula. So let us start with the formula list. The first one is given over here as the probability that there is no one in the system. Okay, so no one in the queue and no one being served. That probability we have to find. This is the most important one, and they are going to even ask questions based on this particular formula in the gate examinations also. You may expect a problem of 2 or 1 marks in the gate examinations, so they are going to ask you based on this particular concept. P0 is the probability with there is no one in the system. It is given by 1 minus lambda by mu. You already know what is lambda and what is mu. Lambda is the it is the arrival rate, or you can say mean arrival rate, or you can say, and mu it is the service rate, or you can say mean or average service rate. Okay, so next is the probability that the customer will have to wait in queue, and probability that the service facility is busy. Okay, so probability that the customer will have to wait in the queue. So it is denoted by PB only, and it is denoted by 1 minus P0. This is P. Okay, this is a P. This is P0. So you already know P0 is 1 minus lambda by mu. That is the probability that there is no one in the system. So PV is 1 minus P0. That means 1 minus 1 plus mu, lambda by 0. That is lambda by mu. So that is lambda by mu only. Okay. So these two are very important. They look like small, but they are in gate examinations, they are going to ask from this particular concept only. And this particular theory, queuing theory, is a very, I think, scoring chapter, as because you only have to memorize these particular formulas all total, and you have to just solve numericals based on this particular formula only. So if you are able to do this particular able to solve this particular numericals on these different models of the queuing theory, you are going to have a big score in the examinations. So let us move to the next part. The next part says the probability that there are n number of customers in the queue system, that is given by Pn equal to 1 minus lambda by mu dot lambda by mu to the power n. Okay, n is the number of customers in the queue system. Now let us move to this next part is the average expected number of customer, exp. I have abbreviated those long terms. Yeah, avg is the abbreviated term of average, and exp is the expected. So average expected no is the number of customers in the queue, that is the queue length, you can say. In short, we will be using this term also. This is also important one, and we will be using this term only, that is the queue length only, okay, in the coming numerical. So queue length is denoted by LQ, you can say LQ is the queue length, and it is given by lambda square by mu into mu minus lambda. Okay, lambda square by mu into mu minus lambda will give you the queue length only. So next, coming to the next one is the average expected number of customers in the queue length, a queue system, or you can say in short, that is a system length. This one is also very important. This is given by ls equal to lambda by mu minus lambda. Okay. Now expected length of non-empty queue. Okay, you can say it as length of the queue also, not actually length of the queue, it is non-empty queue. Okay, so non-empty length of is given by lb equal to lq by p, where n always greater than 1, obviously it will be greater than 1, and lq it is given by lambda square by mu into mu minus lambda, this one, okay, is given over here, and p as you know, lambda by mu is p. So it gives as mu by mu minus lambda. Okay, now coming to the next problem, we have this one, average waiting line in queue system. Okay, average waiting line, waiting time, this one is the waiting time, average waiting time in the queue system. WQ, it is denoted by WQ. We'll be just try to remember these terms. Okay, they are very important. This WQ, LS, LQ, these abbreviations or symbols we are going to use in solving numericals for this particular model only. Okay, so WQ is the waiting time in queue system, and it is given by lambda by mu into minus lambda. Okay, next comes the average time in the queue system. Okay, average time in the queue system is the waiting time plus service time, that is the total time one has to spend in the queue. So this is denoted by QS. This is also important, very important, you must note it down. W is given by 1 by mu minus lambda. Okay, so we have got 4, 1 2 3 4 5 6 are very important, I must say. They are going to you are going to apply these particular formulas in the coming numericals. So one is the P0, that is the probability that there is no one in the system. Next is the PB, that is the probability that the customer will have to wait in the queue. Next is the queue length, that is LQ, and the LS is the system length, and then is the LB, that is it is also used sometime, but it is not so much important as of these ones. LB is given by mu minus lambda. It is expected length of non-empty queue, and the last two important ones are the average waiting time, or you can say the WQ. Okay, WQ is the average waiting time in the queue system, and the last one is the WS, that is the average time in the queue system. So these formulas we are going to use in the numerical. Now we have a problem on the model 1 of queuing theory, and it is very important for your upcoming semester exams also. This type of selected problems I have selected mainly for the semester exams perspective. So you must solve these problems in your home, and you must practice more and more problems like this one, and you will face similar type of problems in semester exams also. So let us begin today with this particular problem of queuing theory based on model 1. So it says customers arrive at 1% barber shop according to a Poisson process with a mean of inter-arrival time of 20 minutes. Okay. Now customers spend on an average of 15 minutes in the barber's chair. Now the question says, what is the probability that a new arrival need not wait for the barber to be free. Okay. Now what is the expected number of customers in the barber shop? And the next one is the how much time can a customer expect to wait for his turn. Okay. The next one says how much time can a customer expect to spend in the shop. And the last one says management will put in another chair and hire another barber when a customer's average time in the shop exceeds 1.25 hours. Okay. How much must the average rate of arrivals increase to warrant a second barber? So I already told you that the first step in solving a numerical in a simple, easy and faster method is to just note it down the given data what they have given. In this particular problem they have given the customers arrive at 1% barber shop according to a process with a mean interval arrival time of 20 minutes. Okay, so arrival time they have given. So let us solve the problem by writing the given data only. Given data, arrival rate. Look, these problems are mainly formula based. You need not to worry much about these particular problems. Just need to practice and you will score enough number. Okay, so 20 minutes given is 20 minutes, so I am converting it in per hour. Okay, so 20 minutes arrival rate is 20 minutes and I have to convert it into per hour. Then this is the process, 60 by 20. Okay, I think no problem that there is a 3 per hour. Okay, that is given by lambda. Okay, now next one is says customers spend on an average of 15 minutes in the barber's chair. That is, you can say this is the 15 minutes is the service rate, you can say. Okay, that is he have to spend for 15 minutes in the barber's chair. Okay, so this you can say the service rate. Now to convert it into per hour, as I earlier told you that whenever you receive data on arrival rate and service rate in any unit other than hour, you have to convert it into hour. So now 15 minutes arrival service rate, that is 60 by 15 gives you 4 per hour, and that will be your mu. Okay, so we have got two data, main two data, that is lambda and mu. Okay, now next it says what is the probability that a new arrival need not wait for the barber to be free. We have to find the probability. A simple formula. Okay, no new arrival need not to wait. No new arrival. Okay, no one, that is the P0. It is a P0 case. Okay, so P0 is a formula we already know, 1 minus lambda by mu equal to 1 minus 3 by 4. Okay, that gives you around 1 by 4. I think it is equal to 0.25. Okay, next says what is the expected number of customers in the barber shop. Okay, expected number of the customer in the barber shop, that means it will be total, that is a system length they are asking. Okay, expected number of customers, that means total number of customers in the system, and we can say it as LS. Okay, that is the system length, you know, total number of customers. So system length is given by LS equal to, you know, lambda by mu minus lambda. So you can see these are all just formula based. Just remember the formula and you are going to score high marks. Okay, so this is 3 and this is 4 minus 3, which gives you 3. Okay, so next part is over. C. Part C says how much time can a customer expect to wait for his turn. Okay, that is waiting time for his turn. For his turn, it says for his turn, that means the queue length only. Okay, so WQ will be the answer. Average time in the queue. It doesn't says that the total time, it says only how much time it has to he has to wait in the queue. That is the queue length only. Okay, and this is the ls means the system total length. Okay, so these are the small things you have to keep in mind. You have to understand the language, what they are asking actually. Okay, average time in the queue, it is given by wq is equal to lambda by mu into mu minus lambda. Okay, so I think after solving 2 or 4 to 5 problems, you will easily get remembered or accounted with this particular formula. They are not very much formula, I already told you. Probability is one of the very important. ls, wq, lq, wq, these are the main formula we are going to use to solve numericals in the semester examinations only. Okay, I'm not talking about the gate or any other. I'm particularly concentrating for this problem for your semester exams only. Okay, so now wq equal to, we have got lambda means 3 by mu equal to 4, 4, and this one 4 minus 3, so it gives 3 by 4. This is time, wq means time. Okay, so wq is the time. So time, it should be in hours, as because both are in hour, I have already converted. So 3 by 4 hour means into 60, it will give around 45 minutes. Okay, so we got wq equal to 45 minutes. Next, last one is the no, not the last one. This one says how much time a customer expect to spend in the shop. Okay, so I have selected particularly this problem because it has got all, it has asked all the possibilities that is going to ask you in the semester exams. So I have particularly chosen this type of problem in where you will get the concept of each and every formula we have used in model 1. Okay, now for the next one, it says how much time a customer expect to spend, total time. Now this is the total time. Total time means it will be the ws. Okay, it will be the ws. So ws equal to waiting time plus service time. Okay, so that is the ws. So the ws is average time in the queue system, you can say. Okay, you can also say average time in the queue system, and it is given by the formula 1 by mu minus lambda only. Okay, so 1 by 4 minus 3, it will 1 hour, or you can say 60 minutes, whatever you want. Okay, so now we have come to the last part. The last part says management will put in another chair and hire another barber when a customer's average time in the shop exceeds 1.25 hours. Okay, customer's average time. Okay, so average time of customers means wq only. Okay, wq, not the total time they have said. You have to understand the language, what they are asking for you particularly. Okay, this is average time in the shop when a customer's average time. Okay, customer's average time is exceeding 1.2 hours, management is deciding to have another chair. So how much must the average rate of arrivals, you have to calculate the average rate of arrivals, that is the lambda, to increase to warrant a second barber. So we don't know here what is the lambda, we have to calculate the lambda. Okay, now to calculate lambda we have to take w, this says average time in the shop. Average time in the shop means wq only. So wq equal to 1.25 hours they have given. You have to find lambda, that is the average, so that the management will, if it exceeds, wq exceeds this much value, then management decides to put in another chair and hire another barber. Okay, so this wq is given, you have to find lambda. Okay, so wq from here only you can write lambda by mu into mu minus lambda. Okay, so you have to find lambda, which gives 1.25 equal to lambda by mu is unchanged. Okay, mu is unchanged, mu you can use 4, so 4 into 4 minus lambda. So you can solve it. After solving you will get around value of lambda equal to 3.33. I have solved it, 3.33 hours. So if the arrival rate, lambda is the arrival rate. If the arrival rate, you have to write the answer over here. If the arrival rate, okay, arrival rate, average rate of arrivals increases to warrant a second order, second Barber, that means if the average rate of arrivals increase to how much? This much, 3.33 hours, okay, then the management will put in another chair and hire another Barber. So that is the solution. You can write it down or take a screenshot over here. That is the solution for this particular problem, you know, based on the model 1. You can also write this problem or take a screenshot of this, and you can practice it without seeing the solution. First you need to practice it without seeing the solution. If any problem occurs, you can see the solution or you can call me. Okay, thank you.